Assalamu alaikum wa rahmatullah. My name is AMMAR Ali FADHIL AL-BAYATI. I am a master student in communication and computer department. I would like to present my project with the name Self-Coherent Optical Transmission System for Short-Haul Communications. My project is supervised by Dr. Zoraida Bitzan. First of all, I would like to present the contents of my presentation. My presentation contains proposal introduction, literature review, research methodology with details. Proposal introduction. Optical fiber transmission is the most powerful technology for providing fast and inexpensive bandwidth for all data services, including 5G mobile, industrial and residential internet, cloud computing, and video streaming. Coherent optical technology provides features that enable multiple terabits per second in association with the other optical techniques such as polarization division multiplexing and dense wavelength division multiplexing. The researchers expect coherent detection will be used in short haul distance since bit rate exceed 400 gigabit per second. Besides coherent optical techniques, there are many other techniques that can provide higher spectral efficiency, simplicity design, and cost-effective for coherent optical transmission and detection. These techniques are used in my project. First of all, coherent OFDMs offers many advantages, such as large bandwidth and spectral efficiency, high spectral efficiency. Moreover, the coherent OFDM makes the system immune to optical fiber impairments, such as chromatic and intersymbol interference. Self-Coherent coherent detection has been proposed to eliminate the existence of local oscillator, laser, and expensive DSP, which are typically used in a conventional coherent detection system, while still providing higher bit rate values than conventional direct detection technique. Polarization division multiplexing is a powerful technique for cost-effective transmission. And finally, a passive optical network can provide efficient solutions to support connectivity for short reach transmission due to their great advantages such as extremely high bandwidth, low attenuation, and low power consumption. Research problems. Coherent short-reach optics have found application in data center interconnection space, which are considered as a key enabling technology for high data rates. Evolving the higher data bit rates combined with the increased baud rate and higher order modulation scheme. The shifting toward coherent optical systems may pose many more challenges to optical networks, such as increased receiver circuit complexity due to the frequency offset correction and carrier phase compensation. My project's aims and objectives is to investigate coherent optical transmission system design for short-haul communication, to design a self-coherent optical transmission system, to analyze performance of a self-coherent optical transmission system for short reach distance. The scope of this project is limited to design coherent OFDM transmitter and receiver that supports several wavelength-based DWDM in both polarization planes, aided by co-propagated narrow line with pilotrons, orthogonally for each wavelength that use as a reference instead of using local oscillator or additional complex DSP recovery circuits. Passive optical network components are used to reduce the cost and the power consumption in the receiver sites. The literature review. Bandwidth efficient and cost-effective transmission system must be used to satisfy variety characteristics such as flexibility, scalability, and low cost per unit bandwidth. Coherent optics has significantly improved the optical transmission system to replace direct detection techniques, allowing for widespread upgrade and new deployment of dense wavelength division multiplexing network with data rates reached to 400 gigabit per second per wavelength or higher. Coherent optics provide several advantages, include improved receiver sensitivity with sufficient local oscillator power to overcome the limitation of the other optical noises like shoot and amplified spontaneous emission noises. Coherent optics provide high spectral efficiency paired with high bit rate per channel, using polarization division multiplexing to double up channel transmission as compared with direct detection. Coherent transmission has become the industry standard for high data rate transmission in short and long haul networks for data center interconnections to enhance the transmission system capacity along with the use of the DWDM system. The basic idea behind coherent detection is to combine the received signal with another continuous light wave emitted by the local oscillator before feeding it into the photo detector. There are two main types of coherent detection techniques based on how the local oscillator frequency is set relative to the signal frequency. This techniques is heterodyne and homodyne. In the heterodyne detection, the frequency of the local oscillator match the frequency of the received signal. And the heterodyne is not much in the frequency of the received signal. And the homodyne detection, the frequency of the local oscillator match the frequency of received signal. The heterodyne detection requires an image rejection filter and twice as much photo detector bandwidth. The homodyne detection requires a phase noise cancellation. My project will rely on homodyne detection where I replace local oscillator with pilot tone to avoid phase noise compensation and frequency shifting to simplify the receiver design. The generic coherent OFDM system consists of radio frequency OFDM transmitter, radio to optical up converter, optical channel, optical to radio down converter, radio frequency OFDM receiver. There are two types of coherent OFDM architectures, direct up-down conversion and intermediate frequency architectures. Direct conversion is another synonym of homodyne detection, and intermediate frequency is another synonym of heterodyne detection. The direct conversion architecture eliminates the need of the narrow optical band pass filter in both transmitter and receiver, as compared with the intermediate frequency architecture. My project will rely on the direct conversion architecture, coherent optical OFDM. This figure clarifies self-coherent system can be self-homodyne coherent system can be implemented by sending pilotons in two approaches. In figure A, the manufacturer dedicated one fiber to send for sending pilotons in a dedicated core. This technique is called the space division multiplexing, while in the figure B, sending pilotons orthogonally with modulated signal using polarized division multiplexing PDM. This is considered as a oasis in this technique, self-homodyne detection. Polarized division multiplexing is considered wasted optical transmission spectrum because all pilotons employ one state and other one state of polarization, and the other employs and the other optical signals employ the other polarization state. The spectral interleaving for self-homodyne detection is a useful technique for lowering the spectral efficiency cost of self-homodyne polarization division multiplexing system. The best cost-effective optical transmission due to the all pilot tones is orthogonal to its optical signal. This approach is the most convenient for self-homodyne because of its simplicity for designing self-homodyne receiver. In these techniques, both polarization states are utilized to transmit the data signal with the frequency shift applied for both polarization states to allow transmission of spectrally narrow pilot tones across WDM orthogonally to WDM channels to improve spectral efficiency by reducing the wasted in spectrum compared with self-homodyne PDM. My proposal will benefit from this technique to design a new simple and cost-effective transmitter and receiver for short-haul coherent OFDM based on passive optical network architecture. This slide is organized as a table to illustrate some of techniques that have been used before and that I have benefited from in my proposal project. These techniques include coherent OFDM, polarization division multiplexing, DWDM, and self-homodyne detection. So my project consists of combination of these related work. As we can see here, these techniques support higher data rate transmission with different distances. Search methodology. The proposed project is based on combining the use of self-homodyne IPDM coherent transmission techniques with optical OFDM and DWDM techniques. This project proposed the use of passive optical network technology for saving some power and cost to compensate the use of overhead pilot tone, which some consider a kind of wasted expense for power for self-homodyne. Passive optical network components used in this project are 3D Kepler, combiner, polarization beam simulators, polarization beam combiner, polarization controller, and array waveguide gratings. This project is designed and simulated using VPI transmission maker. And finally, this project is subject to analysis and assess the performance after optimization measures. This slide clarifies the proposed transmitter. I used horizontal and vertical linear polarization for sending pilot tones and WDM message signal to perform IPDM WDM spectrum. This is the WDM spectra using, this is the slide clarify the WDM spectra using IPDM technique. This slide clarifies the proposed receiver. All my design passive optical components based on real products, such as polarization controller and array waveguide grating. This flowchart clarifies the organization of my proposal project. The simulation is done by VPI transmission maker. The state of optimization clarified in the next slide. The optimization process includes conducting some of tests with VPI transmission maker by choosing the most convenient setup for subcarrier symbol mapping and transmitted optical power to get a maximum transmission rate and the best performance. The optimization process is subject to repeat attempts and comparison of results. In this proposal, coherent OFDM is used as a promising technique utilized in optical transmission to overcome various constraints in optical fiber transmission systems, providing high speed and increased spectral efficiency. Self-homodyne coherent detection is proposed as an useful technique for simplifying the receiver circuit. PDM technique is used to increase optical transmission performance by exploiting both of polarization states to transmit several wavelengths with pilot carriers in an interleaved fashion to reduce the spectral efficiency cost. The proposed system integrates the three techniques such as coherent OFDM, self-homodyne, and polarization division multiplexing to implement and simulate optical transmission system using VPI transmission maker. The proposed system is subject to assess the performance after optimization measures. And this is the references, some of references that I used for my proposal. Thank you so much.